Good afternoon, everyone. Good afternoon, everyone. If I'm here, you got to be here. Thanks very much. I'm Mark Fletcher, the Chief Architect for Avaya. I've been recruited into moderating and participating on this panel, so that means I get to control it, and when they get it wrong, tell you what's right. That probably won't happen. So joining us here today, a distinguished panel, Bernard Aboba from Microsoft. We also have James Cadd from Microsoft, some woman who's wandered in off the street, Carol Davids, who's put together this wonderful conference for 14 years. I heard you say earlier today.
It's true.
That's amazing.
It's true.
You started when you were 20.
That's right. and I'm it's my story and I'm sticking with it.
You're sticking to it.
That's right.
And also Paul Brio from Oracle. So thank you all for joining us here today. We want to talk about web-enabled 911 PSAPs, public safety answering points. So WebRTC, there's no big secret there. It's existed for several years, well-defined, works well, provides clear clarity, easy to deploy, a light application, so to speak. But the problem is that the NINA i3 specification was developed back in 2009, nearly a decade ago. Still not implemented, and we're looking at new technologies and desktop technologies with deploying WebRTC in clients we use to contact 911, and it makes a lot of sense in a 911 center to use WebRTC as the communications technology. Doesn't matter where the call originates or how the dispatcher consumes that can be completely unique, and WebRTC offers a lot of flexibility in that deployment of where and how we get that. Unfortunately, the EZNet is there, and we have to transcode a WhatsApp call with WebRTC down to something on the EZNet, transport it, and then reconvert it back to a WebRTC compatible protocol to deliver to the desktop. When we could go point to point, now that brings problems. But that's what we want to discuss today. We need information like location. We need this data coming from the endpoints. It's a challenge. There's a security challenge. When we open up the kimono, everyone can see. But we need to open that kimono because we need the data. As Bernard was saying, you've got centers now that are consolidating, not just from a public safety perspective, but they're consolidating other quasi-emergency services. Department of Transportation. They don't always have an emergency, but every rush hour they often do. When weather is inclement, they often do. It's an important piece that needs to be brought together. So how do we bring all this real-time communications? Seems there should be a conference that discusses that. So what we're going to do today is we'll start to uncover different ideas and challenges that different people see. And Bernard, I guess we'll start with you.
Okay, welcome. Look, so can I turn on the mic here? Doesn't seem to
Is there a
be.
button?
Hello. Testing.
We seem to be dead.
Hello.
Okay, now we're live. So I think it's important to start this conversation by talking a little bit more clearly about what WebRTC is and what we mean when we talk about it. So WebRTC is multiple things. It is a collection of IETF standard technologies packaged together. I think of it as Unified Communications Package 2.0 because it's a collection. We first deployed RTP and VoIP, and now this is the second generation of those technologies with advanced security and video and stuff like that. So think of it as a second generation of IETF real-time technology packaged together in protocols. That can be delivered to a user or to a PSAP in the form of a web application, or, as James can talk about because he sees, I think, more of the successful applications of it, as a native application, so as a mobile app. And it turns out, I like to say that WebRTC, most of its successful uses are not on the web. So when you look at the total audience of WebRTC, you see mobile apps like Facebook in huge use, right? Compared to the website traffic, it's actually very large. And so I think of it as there's WebRTC, the protocol technology, there's a WebRTC in a browser, there's WebRTC in apps, and those are all distinct things. And so when you think about your deployment plan for public safety or any other app, you have to think carefully about what apps and what context the users are going to be using it in, and also, most importantly, your strategy for testing and maintenance. Because if you talk to WebRTC developers, and James does this all the time, one of their biggest focuses is on how to manage change. Because one of the biggest efficiencies in WebRTC is test coverage. So in many of the more sophisticated scenarios, like you would probably see in public safety, it would be very rare for a browser to be able to go through all those test cases. In fact, they don't even really have them, to make sure that some update of some browser would not bust the dispatcher's workstation in some arbitrary PSAP. So it's very important to have a strategy for containing that change. And typically the way I see organizations do it is they do one of two things. They either freeze a build. They'll say, I'm using, Chrome, the code from Chrome 66, and until it passes all my regression tests, I'm not putting out another build. Or they freeze the browser, and they say, thanks a lot for the auto update, but not in my PSAP. And so that's how they're able to control that pace of change. And so that's a very important part in thinking about how one would do it in a life-critical kind of application like public safety. And then the other thing to think about is WebRTC.org, think of it as basically an RTP stack that is freely available, can be made high quality, doesn't necessarily come that way in every build, but can reach that if you have cooperation to make that happen. I wouldn't say out of the box it is probably something appropriate for a life-critical application, but it could be gotten to that level if there was a concerted effort to do so. And then there are all the technologies around it that are used by it or used to deploy it. And all the wonderful things, a lot of them that Glenn talked about, cloud technologies to create the data centers that allow those apps to scale, artificial intelligence that look at the video images that come in or process the calls or record the calls or analyze them for all kinds of things. So I think what we're talking about here isn't just deployment of WebRTC in the PSAP. It's thinking about how to bring this entire channel of innovation, much of which we talked about in the previous session, into public safety, and not just into the PSAP, but also into the emergency apps. The reality is today, a lot of that technology is being used to build emergency apps. I think we had an FCC app workshop a couple of years ago, and I went and talked to most of the developers. Most of them either were using WebRTC at that time or were planning to use it. So, and James has surveyed this, out of most mobile applications, probably 90% today are based on WebRTC. So it's trying to bring the technology sophistication we have into the public safety arena.
So let me ask you a question, Bernard. You freeze your app at Chrome 66, and that's fine. And then I'm developing another app that's also in use, and I freeze at Chrome 65.
Right.
How do we manage that? How does a PSAP manage that where they've got no IT folks, which is another issue?
Right. So that's
the IT guy is the guy with the AOL account.
Yeah, so that's actually one of the great challenges that you bring up, and in particular, if you envisage a public safety ecosystem that might involve, say, people building apps, right? The college public safety app built a mobile app on, and actually, let me give you a very real example. We're about to have a breaking change probably around Chrome 72 with a completely different STP version. It will make a very big difference whether you froze on Chrome 71 or 70 or 73. And there are a lot of people that will not support Chrome 73. So if you built your app with Chrome 73 and you're calling a PSAP on Chrome 71, very, very bad things could happen. We've actually talked about that in some sessions from time to time. And I've heard the idea put out there of a publicly validated public safety build. That someone out there will come out and say, you know what, for the test cases we have, and whether it's from NINA i3 or whatever, I've run this through those regression tests, and I am willing to say that this thing passes and doesn't, you know, if you're on this build, I probably wouldn't want to sign a legal waiver, but I have some sense that it passed something to the point where, you know, this is what you'll need to do, because you don't want to have 6,500 PSAPs, each running different builds with potential compatibility problems. So there's some amount of validation that would have to go on there, and probably also, frankly, bug fixing and maintenance to a level where someone could feel that somewhat secure in deploying that for a life-critical application. And I don't know in a political sense how that would happen, but if everyone's, and we've seen this, you know, in real life, if you have 1 million people building apps on different builds, that could get unmanageable fairly quickly.
So what if you established a workstation at n-1, and then when calls come in, you do a quick inspect on the browser build calling you. If you've got that problematic call, you route it to an alternative workstation.
Yeah, I mean, there are many ways of managing this, like in an organization. Like, say I'm building a mobile app that interoperates with my data center and my other versions of my mobile app on mobile platforms, right? The ways of that becomes a much more practical problem, because now I'm managing the build. All my apps are built off the same consistent build. I have a strategy by which I deploy this out to the systems, and I do backward compatibility testing in my data center, and everything was great. I'm just saying that life is a lot more complicated when you've got 6,500 potentially independently acting PSAPs. You know, that you can have multiple data centers, but they have to, if they're not running the same thing, you know, a caller from Alabama could then go to Washington State, the Washington State PSAP upgraded, and his Alabama PSAP or his Alabama app or whatever wasn't, and you could get kind of compatibility issues. So I don't think you want to try to figure out a strategy by which you could minimize those kind of things rather than attempt to route around them, because the complexity there could be. But anyway, Henning.
Yeah, I have a question, because maybe I don't understand the model you have in mind. So one model is that you have a campus app that comes to a campus app provider.
Right.
They manage that internally. That's
Right.
a single company.
Single company thing.
Well, I'm not saying it's trivial. Here you could imagine something like Unix does what they have. Many have the LT builds, the long-term builds.
Right.
Guaranteed to be supported for 5 years and pretty much more stable.
And that model that you just described is how almost every app and service works today, and it works relatively well. But
What I don't understand is I don't think we want any random campus safety app directly connecting to any random PSAP in that plan.
Right.
For any number of reasons. Usually they would be SIP signaling, kind of NG signaling involved in that, which is much more stable because it's only signaling. It's not a web browser. Or
Yeah.
you're advocating a much more direct interaction.
Well, so I don't want to suggest that that's the only way that randomness can be introduced into the system, is through the randomness of apps with their own different builds. I'm also saying that when you think of the campus public safety, like you said, it's coordinated across a company, and all of their campus customers will all upgrade presumably at the same time, and all the apps will upgrade. the question would be how you could do that in a public safety environment. Are you saying that you have a service which inherently manages the 6,500 PSAPs and upgrades all of them, and a series of apps deployed in public? For example, you could have an app used by a policeman that would interact with the PSAP. Or just thinking through how you make sure, and maybe the app used by the policeman in New York City is different than the app used by the policeman in Alabama, how you upgrade all of those in a way that they're consistent and avoid interop problems across all the PSAPs and all the apps.
Right. But
Yeah.
and what you're saying, I mean, what I saw is typical WebRTC model is that you have a intermediate provider that has a direct relationship to their users, police officers, whatever
Right.
it happens to be. And they manage their transitions. They make sure that they know their customers individually, in some sense, so that if they see a legacy consumer, legacy customer whose app is about, whose version is about to be disabled for whatever reason, they have ways to reach that entity. The police, either the individual officer or some version of the customer, and actually the police organization that bought the stuff. Having random people, this would be like allowing my SIP desk phone to directly connect to some random PSAP in that. And clearly that way is, nobody would, I assume, would do that for any number of reasons. So everyone, you seem to be advocating a non-intermediated way where the police app of a random Alabama cop who happens to be traveling in New York City directly talks to the New York City
To be
PSAP.
clear, I'm not advocating that. I'm just trying to describe some of the interoperability problems and hopefully bring us to the point of discussing ways in which those interop problems can be addressed, among which is potential gateways that try to minimize this. I mean, obviously, we've learned in the case of SIP about how to try to deal with this variability and used SBCs and other things to do it. So I'm just pointing out that some of those issues don't necessarily go away with WebRTC. That's all I'm trying to say. And in fact, they can actually be, in some ways, trickier than some of the SIP SBC issues, because now we're also talking about potentially large changes in media. Whereas we don't have to worry about G711 going crazy on us and doing something, bizarre. And now we do. We have potential new video formats, new video coding structures. So some of the same issues have to be dealt with.
Dan, from a development point, I'm sorry, James, from a development point.
I was Michael first, and then Dan, and now James.
Right.
Dave,
Dave, good, Jim.
from a development point, what are your thoughts?
Yeah, I have to agree with what Bernard said about the freeze model. That is what we do internally at Microsoft for a number of services that we build, and it's also what we provide to our consumers in the form of an SDK. So what I manage is a UWP, which is Universal Windows port of the Google WebRTC.org code base. And what we do is, since we're a fork, we pick certain releases of WebRTC.org that we want to merge back and periodically update, and then distribute that out both internally and externally. And everyone we've seen internally use this model of, hey, I control my service, I froze at M62, and that's what I'm using until I feel very good about M66 or 71, has worked quite well. I'd also add that other development companies like TalkBox deal with this as well. We had a compatibility issue with them where we had just merged M62. They were still on M61, and due to a certain breaking change there, we became incompatible with TalkBox. So it's important. It happens pretty much every release. The move to updated SDP that Bernard mentioned is going to break pretty much everyone. So it's a real problem, but I think the way you deal with that is by having a service that's providing a lot of this functionality, that's well tested, that you do the interop against, that you've got something like Dr. Alex's kite testing running, and you can see your matrix of, okay, here's our known good, here's Firefox and Chrome and Safari and Edge, and how they're working on a nightly basis, and keep track of that kind of stuff.
Carol, as a developer and someone who runs a development organization, really, of researchers, how does that impact your thinking?
So I was going to say that these are very important, really, implementation problems from our perspective, and that what we were also considering and we were interested in talking about today was, let's assume these problems go away.
Okay.
Let's assume, because we're engineers and we know we can fix this, and a lot of this is going to be policy and operations maintenance and support of crucial things, and wonderful to bring them up and talk about them and find good methods. But if we were to do that, then what do we do with the right now we have the emergency services IP backbone network, and we're feeding, we actually have an interworking function at the entrance, and we have another one at the exit, so that we can turn again into a web, either a native app or into a WebRTC, somebody that the PSAP can be looking in the browser for. So looking at that, what changes and what stays the same as we do the routing and we use the location information to, first of all, route ourselves to the appropriate PSAP, if most of the time we'll be doing that, and then second of all, to be displaying that information. So we're needing to send that information in one way or the other to some cloud or network or EZNet, and it pops out on the other side. We did an all-web solution saying, we know this isn't the standards, but we want to see where we can go with this. And this was a proof of concept, and we found that so much could be put into we did this using AWS, and so we had a database sitting up there, and we have APIs, and we have back-end servers that are calculating your location, and this was specifically for indoor location, but the same would apply for outdoor location. And where are my databases that tell me which PSAP to send to, and how does that work? It was the mechanics inside that we were interested in talking about, and I thought in particular about current efforts to build EZNets, and the fact that the problem we're discussing, having to do the double interworking, is also being faced there, where some of our SIP calls are having to be translated into SS7 calls in order to be carried across some backbone before they are again translated into SIP calls, and how sort of wasteful and inefficient that is from the perspective of the technology alone. And I know that in some cases it's just that you need to have your infrastructure, and we don't have the SIP infrastructure. But so that was more, I was hoping people could begin to address. How does routing change? If we were to go there? So this is, again, the experiment. This is the experiment. This is, we can do this because we're a university and a research lab, right? What stays the same? What are the functions that would be changing from what they are today? What is specific to SIP, and what is going to be more native to WebRTC?
Yeah, I don't think that the location routing changes much. The forest guide could still be the forest guide and could be used to determine, where calls go and all of that stuff. So I don't think that part of the system really changes. Where things might get interesting is if you're trying to do a better job of serving disabled users and take their needs into account. As an example, video is part of your ordinary call, then things like the video relay service become a lot easier to build and incorporate into the system, right? Because video is always there, and the system is built to handle video. And it has the appropriate frame rates and resolutions to do that kind of stuff. Also, within a WebRTC framework, you'll typically have access to cloud services, so you can bring in things like transcription or translation, so a lot of the language issues become easier. RTT and things like that become a lot easier to implement because they're kind of native to, you're already running over IP. So I think your ability to serve the disabled will probably be much greater. I'm not sure the routing changes much, because location is location. You want to get it to the same PSAP. It's just what it would be able to do could be dramatically upgraded without having requirements on the dispatchers. Right?
I think the change that you'll see, and we discussed this years ago on the EAC, you're going to move to a three-way conference so
Right.
the dispatcher can see real-time the origination caller and the translator simultaneously.
Yeah.
And
Yeah.
you've got fact-checking that can take place, and everybody can hear background audio, et cetera. So that's the fundamental change from an ADA perspective. But
Yeah.
I'm interested to hear what Paul's got to say about the implementation from an Oracle perspective, because you're the let's say the commercial consumer of all of this potentially.
Before he does that, I wanted to go back to this question of, we found you put a tag on this call, you can put the location right up there
Yeah.
onto your server, and we didn't have to carry it in any body. And since we're real time, wherever we're delivering it, we can pull that out of the cloud, and we don't have to carry it in the data channel, for example. Or for the first round of this, we carried it in the signaling channel, actually, because you can put it anywhere you want. And then realize maybe we're trying to hew too close to the old SIP architecture. Maybe we don't have to carry it in anybody's body. Maybe we just throw it up here, and then whoever gets this call, we pull it down.
Yeah, but I would caution here, because the I3 standard and where we are today, we're not in a greenfield scenario, right? And location and mapping and all the functions that go into the I3 architecture were well considered. Maybe they're not where they would be if we would do it today, but they are where they are right now. So WebRTC provides just another way of communicating, right? It's simpler. It gives you access to the public using standard technologies, blah, 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 all that stuff. But we still have a dispatcher who needs their operational procedures, unless we're willing to change that. We still have mapping that's customized to the jurisdiction that is doing the mapping. We still have location, which is different from GPS and Google location, right? And then there's also the regulatory and legal aspects, which is one of the things that stops people from getting into this business is the fact that there are regulatory and legal hurdles that are unknown right now. Nobody's adjudicated this. And so who's liable when it doesn't work, right? And so there's a lot of factors that go into, well, we have something today, and it works, well, kind of, and there's a lot of things missing, and blah, blah, blah. But introducing WebRTC is kind of like this pie in the sky. Well, let's get rid of it all and start with WebRTC. That's not going to happen. Right?
It is happening. WebRTC is ubiquitous in private public safety applications.
Absolutely.
Let's make that clear.
So I
it's
deal with
happened.
WebRTC is out there. I deal with my contact center customers all the time who want to engage with their customers using SDKs and WebRTCs and have multi-channel interactions into their contact center. Great. It works fantastic. But in the public safety sense, you have to now reset all the requirements.
In
I'm
Europe,
just
there are
saying.
entire countries that are
I'm not
using
saying-
WebRTC
the
today
point isn't if we
to analyze traffic video. Don't say that this isn't in public safety. We've got an entire business that does this for a living outside the United States. This is not pie in the sky. This is deployed stuff in a number of countries in Europe. Not necessarily for call handling, but for traffic
I understand.
analysis.
And I've got to say, we are stuck on yesterday's technologies. I was just in an RTT panel at the FCC last week, and one of the comments made from a 911 database provider, how is location passed on RTT? Well, we're going to tie it to the phone number. I about fell off my chair. It's like I'm sending my email to you with a teletype. What, are you kidding me? We need to start moving forward. Yes, it's new ground,
It's not.
but we need to blaze these
Well,
trails.
the point is that if you want to rebuild, so we went from 911, U911, and then NG911. It was about a quarter of the country on NG911, less. Right, so very little penetration, yet it's being considered basically broadly. So do you stop that and restart with a completely new model? Do you rethink all of the requirements that are put on? Now, so I was the architect for Massachusetts NG 911, right? We had to blaze a trail on the regulatory requirements, on how do we interface into the local carrier, whose responsibility is selective router, who pays for the selective router, how do we pay? I mean, there's so many intricate details about how to reconstruct the E911 into a private model, getting away from the LEC model. So are you going to restart that, or are you going to eat this elephant one bite at a time?
Well, so let me give you an example of last year. In this very room, we had a 911 panel, Next Gen 911, and one person on that panel was a representative from the Chicago OEC. And he talked about how 5 years ago they did a major forklift upgrade overhaul of their communications network. And someone from the office, or from the audience, said, "Are you Next Gen 911? No, we have to upgrade." That's what the last upgrade was for.
Yeah.
So again, citizens, I believe, are not going to stand for this continual upgrade. And the problem is that citizens, the consumer, is becoming educated. When I can do these things on my device for day-to-day communications, when I can do these things for commercial communications,
And when you
and
can do it
911
with
says they
when
can't.
you do it with private public safety applications,
yeah,
right?
they say, why can't I do this with emergency services? So, unfortunately, you have to use the F word, and that's forklift.
I thought you were going to say the F word was
Facilities.
the F word was federal.
But the point is, yeah, okay, eventually. But there are other means of doing this. So over-the-top voice isn't necessary if you can do voice using the existing i3 model and do over-the-top video. So there are lots of ways of introducing WebRTC in an incremental fashion that works with the existing infrastructure, and then put into place, the mechanisms that will allow for the mediation between those two worlds.
So one thing there, though, I mean, as my father would say to his two daughters when we argued, you're right, and you're right, and you're right, too. So what's happening is that I think we're talking about there exists the possibility to do something else, and you're speaking quite correctly about the fact that right now we have situations in which we're being blocked in Illinois right now to put in NG911 networks, partly by the complete lack of understanding of the legislatures and the judiciary, who we had to explain what layer 2 was to. I mean, seriously, they don't understand, but they have laws whose language is too specific to an outdated technology. And those laws, and this is the same thing that happens to us in standards. So we mistake the function for its implementation. And then we write this rule in such a way that we have to write a new standard because, our detailed requirements are specific to whatever the current state of the technology is. So what we're talking about is simultaneously, while you're putting these in, and I am working with people who are trying to get the NINJA project here, which is the Northern Illinois NG Association, and they're blocked right now because of basically laws that too specifically speak of outdated technologies. Okay, so yeah, I work at that end, but also we have to be in parallel working where, looking at which functions are truly the high-level functions that we need to keep, and which ones are specific to SIP or were specific to even an older technology. I worked on MGCP standards for a period of time, and I was like, oh my God, I'm translating everything that I was doing on the old telephone network. This is the most boring work I've ever done. It's like, why are we doing this? And, let's make optimal use of the fact that today we have the ability, we've really said our transmission layer has now been lifted up to layer 5. We're now at the session layer where we used to be at the IP layer doing this stuff. So how could we optimally use that? Not saying we're going to go,
Yeah. And by the
We
way,
can't get rid of what we have.
the point needs to be made. WebRTC is coming whether the PSAPs like it or not. And let me give you a specific example. There are traffic cameras all around the world. Those cameras are, in many cases, being built only with WebRTC. They're using the WebRTC stack. They're transmitting video with WebRTC formats. So a PSAP that says, I don't want WebRTC, the answer is you're not going to get the camera traffic because those cameras won't be built to do it any other way. We're seeing that across the device framework. So that's something to understand. This is something that's taken over the ecosystem, right? You want devices, you want apps. It's like the PSAP that says, I want to run camera trunks. Well, how long is that stuff going to be available? Or I want to run based on, switches, ES switches from God knows when. At some point, you're going to be scrounging spare parts on eBay. The technology has passed you by that far. So at some point, you get to choose what technology movements you get, but in other parts, you don't. And particularly in the traffic analysis section, that's all WebRTC in large portions of the world because that's the only way you get the video formats.
And last year, I'll remind you again, we had Senator Jennifer Bertino-Tarrant on the panel. And one of the things that she said was the biggest challenge for her is that she doesn't understand any of this stuff. Yet, she's legislating on it.
So the last thing, I think everybody will agree, the last thing you want to do is get into a jurisdiction by jurisdiction open development environment where everybody can pick the method and mode and means of communication that they want. Because the system is intended to be national, right? And so if you're going to have a national system, you have to have a national approach. And that requires requirements, it requires some vision, it requires leadership. That doesn't mean that things can't be introduced incrementally, with knowledge of how it's going to operate. But you can't just throw out the baby with the bathwater.
But
But
how does
when
that...
you have 6,500 endpoints
Right.
that need to get in line, that's a big stick.
Is there a secret way, because what you've just described is a problem that would occur with any technological change, not just WebRTC, but how does that national coordination occur, right, at any level, right? I understand how it occurs if you have a unified service like the models Henning was just talking about where it's one provider. I understand that. It doesn't matter if you have 6,500 decision makers. If you had 20 decision makers, right, you would still have that issue.
We can't even agree with 4.
Right, exactly.
And just to your point earlier, we had a hackathon here this weekend. It was TADHack, so telephone application developers. There were 5 contestants, and 4 of them did their application or service development for emergency services.
Sure, because they can build an app.
They can build an app, and they were almost, I believe, all using WebRTC, and we are in that innovative state. There's going to be another hackathon this weekend for FirstNet application developers that's sponsored by AT&T on the same campus, and we're going to see another bunch. And so the interest is there. We are now exploring. I mean, this is that crazy experimental stage for young developers or for developers. So that's at the edge, and eventually, I would hope, we'll do some research based upon these developments and decide perhaps and move forward. The danger with this is that we just keep discovering all these other wonderful applications and we spawn many, many services and there is no centralization. So that
Henning,
Public
go ahead.
safety is...
Somewhat confused. Maybe this is part of the discussion now, somewhat different things. So maybe Bernard can explain it a little bit more. I'm trying to understand in a kind of your idealized WebRTC type of environment, maybe how you would mind. So there, in my view, kind of 3 or 4 parties that are generally involved, besides kind of on the legal side and on the technical side. I mean, the carriers, where you dial 911 and something's supposed to happen. So you could imagine a WebRTC model like the campus security app that we basically say, carriers, you've had 15, 20 years, you're not really getting on, you're stuck in SS7 land and camera trunks and all of that. we've had it. You're out of an M1 business. We just tell everybody to download the WebRTC M1 app. And let's say there are certainly moments where that strikes me as at least a good political strategy, because that might be the one way that they'll actually
And there are
finally do something.
campuses that have done exactly that for students on that campus. It's
Right.
not a 911 solution for the city. It's for
Right,
that.
it's more constrained environment where you have a much more direct interaction with students in that case, and so on. And you can, and in the worst case, they can still dial 911 even if they forget to
Yeah.
download it.
And to be clear, they're dealing with campus security, which is essentially one PSAP for that.
Exactly. So it's a very simple, I mean, relatively speaking, simple environment. And so the second part is the whole call routing, the location type of stuff. And then we get to the EZNet, and then we get to the PSAP side. And so clearly you could have on a PSAP, they could decide instead of actually installing very expensive call-taking software, we're going to run WebRTC. And I'm guessing the European example is probably closer to that, so that it's a cloud-based model where all you need is a web browser or some other app that hosts your WebRTC thing on a PC, and you don't have to go to Airbus and buy CAD software.
Yeah, I would say that in the European cases, a lot of them are running, I believe, native apps with things like the James's UWP SDK rather than browsers, because that allows them to control the pace of change
Yes,
better.
but it's on the PSAP side.
It's on the PSAP side.
I mean, people still dial 112,
Right.
from what you understand. And so maybe that, in your discussion, would be helpful to have a better sense of it. We don't kind of beat straw men here. And I mean, this goes just, I'm not excusing you of being, I mean, in the sense that I think your concerns are over a particular model, which may not necessarily be the one that Bernard is talking about.
But also-
Practicality of what we're talking about?
also
There's
be
a lot
clear-
of technologies that work, and WebRTC works fantastic.
Yeah.
But what's the practicality of deploying it in today's non-greenfield model?
Yeah.
It has to be,
It turns out it's not the greenfield that matters most in Europe, because Europe you have a certain amount of homogeneity. First of all, the number of PSAPs is way lower,
Yeah.
right? So you have 2 PSAPs or 3 PSAPs. That's a lot different from 6,500 PSAPs. So it's not the fact that it was greenfield or not greenfield. It's just the decision makers are dramatically fewer. The deployment hurdles are much lower, right? So it's easy to change. You know, if you're a country the size of Liechtenstein, right? Not a huge deal.
Yeah, I have a question. You guys started this without actually doing a presentation. So there was no architecture proposal. I was trying to figure out what it was that you're proposing just through the conversation. So is the proposal that, given the previous conversation, the proposal that you want the PSAP side to support WebRTC, but on the consumer side, the subscriber side, it's today's communication system?
No.
No. Okay.
No. The presentation is that we can have a native app, for example, as Bernard is saying, on your phone. And right now, the cellular service providers have actually been trying to put some kind of application code, probably in firmware, just deliver the phones that have this, that would right now perhaps be giving you a SIP call, or that would be doing it. So you do that on one side, but it's with a WebRTC type of an implementation. And then the PSAP is also WebRTC. Today you already are able to do that, but you do an inner working function at the left-hand side and the right-hand side. So you're doing web on the outside, and then you're coming into this gateway, and I believe you've got that gateway. I mean, Oracle has a translation right there that'll make you into a SIP call, route you, that's going to be your gateway, route you across the EZNet, where you are picking up the location of the PSAP that you should be routed to, all that, and then you
So-
pop out at the other side.
So you want a
Yeah.
completely separate 911 network for supporting
There
911
already
calls?
is that backbone. There already is that backbone. It's called the
Okay.
EZNet.
It's based
Yeah.
off of telephony, right? And that's the problem.
Yeah.
911 is built off of telephony. In the old world, it was your black phone, and now it's becoming obviously cell phone and texting. But not NG 911 is based around location, improved accuracy, and non-black phone, right, into cellular. But that doesn't include a whole bunch of modes of communication that you may want to do, like video, like presence, like chat, like screen share, like a lot of other things that are out there that isn't included in the telephony environment.
Yeah.
So I think this whole discussion's about, hey, when do we start looking at those things, and why are we operating on this really old, new technology?
Okay.
Yeah,
But
I'd also like to make just make one point, which I think we have brought up in other contexts, such as location, which is that we saw some real advances in the ability to provide better location to the PSAPs once the functionality went into the mobile phone operating systems. I would actually make the same claim about WebRTC, that if today no mobile phone operating system includes a standardized WebRTC library in it. Every app uses their own build of WebRTC. If say Android or iOS were to contain a single WebRTC library validated by those manufacturers for use in emergency calls, among others, a lot of this dysfunction and interop problem would go away. Just like when the location functionality went into the OS, it became much more possible, as opposed to saying the PSAP would get location from 1 million apps. Right? There's a convergence there, I think, that could move this along dramatically and obviate a lot of the issues we've been talking about.
But again, it starts with the requirements. And the requirements for NG911 are phase 1 and phase 2 location. The requirements for NG911 is not to use GPS for location and not to use Google Maps. Those are the requirements that people have to live by. And if you don't follow those requirements, you're non-compliant. So change the requirements, and then we can do a lot of different things. But right now, you have to go with what the requirements say. Otherwise, nothing's going to work together, and all jurisdictions will be incompatible with each other.
What's T-Mobile doing to deliver wideband? Do you know?
No, not off the top of my head. I mean, you mean wideband voice, or?
Yeah, so if you have a T-Mobile phone, you call in a T-Mobile user, clearly it's 722.
Yes, that's my understanding, but I'm not an expert on how they deployed it.
Just wondering if they have a WebRTC or some other, what client they're using to deliver that.
I don't believe that any major carrier is using Opus at scale today because of some of the decoding and encoding performance issues.
I'd like
But
to
it's
know how
used
they're doing
elsewhere
that.
very widely.
Yeah, and I could add, we use that internally at Microsoft. We prefer Opus for a large voice chat, not Skype application that is built actually on ORTC lib. And due to those issues with encoding and decoding, essentially we built a large SFU that runs in Azure and can forward Opus packets from the standard Android and iOS WebRTC clients and translate them into another system that it functions with. And that's running at scale reliably today. The one thing I don't know how you get around is that a lot of these services have like a 99.99%
Right.
SLA, and that's in the best possible scenario. And if they fail, they give you money, right? And that's not going to help in this scenario.
Yeah,
So
I can tell you there's no WebRTC service that comes close to meeting a 99 point, and not, even a 99% SLA, let alone 99.9.
So I don't know what the fallback is, but you can't just throw away everything that we've got now that's reliable and move wholesale. There's probably some half step where you've got some clients that are more modern, that are able to use this stuff and can send things like real-time video and data from a device. You know, you've got all these sensors with all this data that's generated. Why not make that available to the emergency operators?
Yep.
Okay, we've got about 8 minutes left. How about 2 minutes each to summarize?
Sure. So, I mean, I'm not a disbeliever in WebRTC. Again, we deploy it with our banking customers every day, and they interact with the customers this way. Again, screen sharing and chat and voice. All I'm saying is that the reality is that we're all we are. We have to operate in that environment. WebRTC is a phenomenal tool that we can introduce into this environment and eat this elephant one bite at a time. And one of the considerations is possibly using it for video only, but using non-over-the-top voice. And again, and not that the voice is any worse, or not that we can't do it. It's just that the incrementalism is that we already have the mechanism set up. We already have until the requirements change, until the legalities change, until regulatory catches up with this, we got to do it slowly.
Thank you, Paul. Carol?
Yeah. So remember that when the EZNet was way out there, wasn't that many years ago, and it was a research and development project in university labs and at the ITF. And so this is what we're doing is watching the continued curiosity of human beings to see what does this new technology allow us to do. But the EZNet isn't that old in its concept, and I mean, although in our current time, 9 years is like a generation or two, but that's how it started. What could we do if we wanted to port this 911 service, if we wanted to port it over an all IP backbone? And it was only over a backbone, interesting, because we've never figured out actually in the real world how to have an all SIP, say, or an all IP telecommunications system either. So the idea was, let's get this backbone. So that's what I'm talking about in this conversation, not how to actually do this tomorrow. And in fact, as I said, we work with trying to bring camera trunks and SS7 trunks, and so this is real, engineering. That's how do we bring all these into an EZNet? But we need to also be thinking that maybe 10, 12 years ago, EZNet was on the drawing board, and that's what we're talking. That's certainly what I wanted to talk about at this panel. Yeah.
Thanks, Carol. Ralph? James?
Close enough.
Michael?
Fred?
Fred, yeah, Fred.
Fred?
No, I like the point about eating the elephant one bite at a time. Right. And I recognize that we need some regulatory change in order to make this stuff happen. If we could all agree on a version of the spec that we like, that's supported, on a version of the library and where we get the bits from so that everyone's compatible, there's just so much more we can do. We have projects internally where we've got WebRTC feeds going from people's webcams into AI services to do things like measure heart rate, their sentiment, do the TTS and STT that Bernard was mentioning. There's so much we can do once we move there that I'm just hopeful it happens even 10 years from now.
Thank you. Bernard?
Yeah, I'd like to underline what James said. A journey of a million miles begins with one step, and we're seeing WebRTC come into public safety. The initial applications, as we said, are kind of under one management, and I think we'll see it come along slowly and prove itself. Just like any technology, you have to have references before you get bigger customers to adopt. And we'll go through these cycles where we'll have universities, we'll have apps oriented towards segments of the population adopt it, and then eventually we'll get over some of these reliability hurdles, some of these versioning hurdles, at making our way from a niche application into a wider deployment. But you've kind of got to take it a step at a time. And I see it personally being more like a 10 or a 20-year journey. But it is being used in public safety. It is coming in. It is being used in real apps. But we're just trying to prove ourselves step by step.
Thank you. So I think we've had an interesting discussion today. Clearly, it's time for a change. And I think we need to stop thinking in today and yesterday and start thinking into tomorrow. And, the reason why we do things today, it's all the FCC's fault.
Right. Not exactly.
Oh, okay. The two guys right there. Thank you very much for your time today. Appreciate it.